en Cristo en Italia. Está trabajando con lo que es el CANSAT también, está haciendo varios proyectos bajo este tema del CANSAT, que usted ya sabe que es sobre lo que es el equipo satélite. Queremos platicar un poco acerca de eso. Okay, now it's time to start the presentation. Please, Mustafa,
Start
can
now?
you start?
Yeah, I'm ready. Ladies and gentlemen, welcome to our presentation that's about CANSAT by the Space System Technology Lab. What is the CANSAT? In the next video, the idea will be clearly discussed. Now the CANSAT has a size of 65 millimeter diameter and height of 110 millimeter. It used a rocket to launch the CANSAT to a height of 15,000 feet. After reaching to this height, some doors open to throw the CANSAT in the atmosphere or in the air. The parachute of the CANSAT starts its mission to land to the ground with a falling speed or descent speed to reach to the ground safely. At this time, many data sent to the ground station that explain what happened or what is the parameters of the atmosphere around us, how is the pressure, the temperature, the humidity, and so on. Some about the dust around us, how the space, the small space in our atmosphere, it be what it consists of, how the difference of layers of the atmosphere we can notice. For the next 1 hour, I will present the CUFA CANSAT or Cairo University Faculty of Engineering CANSAT. The picture on the right is for the inner structure with PCB or which printed circuit board. The picture on the left is that's closed inner structure of the CANSAT. The picture on the middle is the outer structure of the CANSAT. The CANSAT mainly, a completed system, consists of several subsystems. We can say that the CANSAT subsystem is mechanical and electrical. Electrical is consists of code, printed circuit board, ground station, while the mechanical system is consists of recovery system, mechanical design, and structure. The code, which is the controlling code for the embedded system we have, while the printed circuit board with all sensors and the microcontroller also on it, it's the creative integration between the electronics from level of transistor to the level of the integrated ICs. While the ground station is the station on the ground that receives the data from the CANSAT and then do some processing instruction to display the received data in diagrams, charts, meters, or make decision or send control signal to the intelligent completed advanced CANSAT system. While when talking about the mechanical system, we have the recovery system, which is the system that keep falling off the CANSAT in a constant descent rate to protect the body from shock effect or collect the crashed body parts everywhere. While the mechanical design is the mechanical mechanisms designed for some advanced types of CANSAT for moving parts, separate parts, and so on. While structure is the parts around the CANSAT that collect all parts together and reduce the shock if unfortunately the recovery system breaks down. Let's talk about the CANSAT mission includes. The mission of the CANSAT that we finally designed have a specific mission that can be included in, firstly, weather forecasting. The weather forecasting such as pressure, temperature, humidity, carbon dioxide percentage, oxygen percentage, and dust level. We have the pressure and humidity, which is the percent of the percentage which present the percentage of the water vapor in the atmosphere.
Excuse me, Mustafa.
Yes, sir, I can hear you.
Mustafa,
Yeah.
can you hear me?
What?
Can you can you speak a little more slow just for the translator?
Okay, I will try.
Possible?
Oh, yeah, it's
Okay,
possible.
thank you. Thank you.
You are welcome. The, the CANSAT mission includes weather forecasting. The weather forecasting such as pressure, temperature, humidity, carbon dioxide percentage, oxygen percentage, and dust level. In the past, we were forced to use some mechanical equipment to estimate the weather conditions. It was not accurate and had a lot of problems. Today, some modern equipments are used electrical sensors are used to detect the weather and predict what the weather will be in the next few hours. In our weather forecasting, we need the pressure and humidity, which is present the percentage of the water vapor in the atmosphere. The temperature of the surrounding of the CANSAT, not the inner surface of the CANSAT. We have 4 ways for determining the temperature. Firstly, we can use BMB 085 or BMB 180. Both of them are temperature and pressure sensor. We have also DHT 011, which are both of them humidity sensor. We have also LM35DZ, which is analog temperature sensor. We have DS18B20, which is digital temperature sensor. In our applications, we need to find the value of the pressure and the value of the humidity. Also, we need to know what the temperature is. So we use both of BMB 180 and DHT 011. Secondly, live image and video processing. In this video is a test for our CANSAT. On the left, show the camera integrated with the CANSAT. On the right, external camera detect the following test. Allah! Now we have TTL camera and the CANSAT that capture photos and videos, then transmit them to the ground station to provide live video processing of the land down to the CANSAT and side view of the clear blue sky with the land view while the CANSAT in the sky. Also, the camera have infrared night vision. Third point is angular velocities and accelerations. Now we have a simulation of using IMU sensor to determine both of the angular velocity and angular acceleration, also with determining the Euler angles. Angular velocity and acceleration, that we use IMU 6050 to determine the angular velocity in the three axes x, y, and z, to determine if the recovery system is stable enough or not, and by small calculation can be used to determine the direction of the wind around the can set. Now this is a simulation for the IMU and show that how any small motion can be displayed on the ground station. We have Euler angles, we have zero and roll and other angles. The error in the value of the angles is so small or can be neglected. This is a photo of the processing program in the Iran competition, CANSAT, Iran competition for the CANSAT in 2013. Now this another simulation for the IMU shows that the gyroscope values and the altitude and so on.
La simulación de la estación terrena, ahí pueden ver altitud y otros datos de temperatura. Let me, a few minutes, just to explain this interface, please.
What?
Interface. Let me, a few minutes, just to explain this part in Spanish.
Okay, take your time, sir.
Thank you.
You are welcome.
Un nivel más avanzado en cuanto a lo que es ingeniería electrónica y lo que es también la parte de la electrónica. Para los que no están a de música, tenemos a ver unos cuantos meses por ejemplo, o entonces, este dispositivo hace la transmisión de datos hasta una estación de red. La siguiente programa que como pudieron ver, muy bien, puede ser y lo que está haciendo es llega a la computadora, a la laptop, puede llegar en forma, por supuesto, datos, ya por horas, tienen el número codificado, el número que no tenemos de la primera capacidad de poder transformar estos datos en algo que nosotros entendemos. Como decir ustedes, cuando ve la temperatura de cualquier aire acondicionado, pues lo ve como 20 grados. Y de la temperatura de la presión física de esta unidad no ve este valor, sino lo transforma para que nosotros podamos conseguir. Entonces, aquí lo que van a ver es precisamente que periódica altitud, temperatura, para poder ir identificando los datos en el proceso de la vida.
Yes, complete? Okay.
Yes,
Next,
yes.
next we talk about the Euler angle determination. As we know that the angular velocity is the first derivative of the Euler angle, and the angular acceleration is the second derivative of the Euler angle. So we can use this relation in determining the values of the Euler angles as a function of the time delta t. With integration, we have to use the basic concept of the integration. Then Euler angle equal angular velocity multiplied by the change of the time. But the change of the time in the time but the change in the time is the time difference between the previous data manipulating and the current data manipulating. We have many sensors in the CANSAT with great time requesting function. So the value of the angle is not so accurate enough. So we are forced to use the ADXL345, which is not so accurate in determining the value of the angular acceleration, as there is no gyroscope in the design of the sensor. After that, we talk about the altitude. To, to determine the value of the altitude that the CANSAT is in, we have a variety of solutions. We can use the aerodynamic formula that's height equal function of the pressure and temperature, which is showed here. That's the pressure over the standard pressure equals the exponential of the negative, the gravity over the constant gas or the universal constant gas multiplied by the temperature in Kelvin and the difference in the height. So we can use pressure and temperature sensor PMB 180 or PMB 085, or we can use the GPS as one of the data that the GPS module receives at the altitude of the module, which is already integrated in our CANSAT. Then we have the position or the GPS coordinates. We determine the current position of the CANSAT by using the GPS module. We receive the coordinates of the position as the altitude, longitude, and latitude. With high baud rate GPS module, we can find the small change of the coordinates on the world map in Google Earth application with real-time position determining. And this photo is a photo of the CANSAT competition in Iran. And each point represents the place of the CANSAT at a moment.
Okay, that's fine. Continue, please.
Okay. Also, this video show how that's the position can be determined. This is a real-time processing of the GPS coordinates on the Google Earth application to show which place we are now and count the speed or estimate the speed of the movement in mile per hour.
cambia el idioma, entonces creo que ahora creo que entenderlo. Nuestro banda y las palabras de entiendo todo. Yo ya entiendo. Well, you know, and this is the national so here is by someone from Egypt. His native language is Arab, but he's speaking. So it is the most universal language. Why we listen to the lecture is not in Arab. So that's why we do study English. Dr. Lawrence is English very well. Yes, very. I know. He has his family and his daughter very, very good. So English is the language of the world. If you can go anywhere in the world, you can go to China or Europe, whatever country, you can English. Do you understand? Okay. Some people have a very peculiar, for example, the natural is basically English, but there is something Arabic accent. You understand? La persona que está hablando tiene que aceptar el pequeño acento árabe, lo cual puede identificar.
Okay, complete now?
Yes, please. Yes.
Okay. Now talking about the separation system. In the CANSAT competition of the Texas, the specification required 2 parts CANSAT. Firstly, 1 part from the rocket, then the second part separate at the height of 500 meters. The upper part used the parachute to land on the Earth with 12 meters per second falling speed, while the second part landed with 10 meters per second speed, without using direct speed drop like parafoil, parachute, and etc. While in RLS competition, the case is different as more specification. Yeah.
Can you put it here, please?
What? What?
The presentation is no. We can we cannot see the video.
Yeah.
Your
Okay.
presentation in PowerPoint.
Just a second. Now is it okay or what?
Let me Okay, that's fine. Thank you.
Okay. Complete now? In our CANSAT, there is several modules. Firstly, we have 80 mega which is Atmel 328, which is the microcontroller, AVR microcontroller that we used using Arduino. We have also the pressure sensor, the temperature sensor, the humidity, the GPS module, the audio, the storage, which is SD card module, the data sending, which is XP Pro Series 1. We have Euler angles determination. We have angular velocities and accelerations. We have head determination. And we have TTL series JPEG camera. All of them are our CANSAT sensors that we use. Actually, this sensors is not essentially for any CANSAT. We use it because we have some category that we must satisfy in some competitions like Texas competition, RLS competition, and Iran competition. The first thing that we have is the data acquisition. That we must collect more data about the conditions or the parameters of the atmosphere around us. Our mission is the only thing that say to us you must use this sensor and not this sensor. Our CANSAT can be described easily by these points. Let's talk about the code or the controlling code, which is firmware. We have many types of microcontroller that we can use. We have Arduino Uno, which is not a microcontroller, but it's AVR development kit. We also have Arduino Mega, which is also a development kit, but the difference, there is more input and output, which is and more digital and analog pins. We have more faster than the Arduino Uno. We have also PIC microcontroller, and we have many families of PIC. We have PIC 10, PIC 12, 16, 17, 18, 24, and 32. Our CANSAT that we can do, it can be programmed on PIC 18. We also have AVR microcontroller and Raspberry Pi, which is considered one of the most strong microcontroller with Linux operating system. We have Bagel Boom Black also. To just explain what the microcontroller is, it's an ALU with some instruction register, with RAM and some instruction decoder. We have many peripheral input and output ports, and we use some interface like SPI, I2C, UART, USART, UZART. We have ADC converter, analog to digital converter. Some microcontroller has digital to analog converter for some applications, for some motors and so on. But finally, we decide to use Arduino Uno, which is a development kit for many reasons. Firstly, IC of the microcontroller, which is Atmel 328P, is with 28 pin. It has no weight. The weight is just 5 grams. It has many digital input and output. It's a board I2C and SPI interface. It has ADC converter and easy to use with no need for all the board. It's just the IC that we need. We have also many programming languages like C, Python, Arduino C, Java, C++, and we have applications which is more important for PIC microcontroller, which is Microchip MBLab. In Microchip MBLab, we have the ability to use Microchip C18 and Micro C high tech, and we can use the assembly. But finally we decided to use Arduino C. The language that we use in our applications is Arduino C because it's so easy to use. There is more libraries for it, and all sensors have feedbacks and many problems detection. Also, Arduino is an open source kit that can be easily developed, and many solutions are can you find it and when you do a search. Secondly, we will talk about the ground station. This is a map ground station detection. Another map detection for the position and some of the angles and some in this face or in this picture. We have angular rate change and servo. This is a simulation for the IMU. It's like what we have discussed before. Another IMU simulation for the 3 angles in the space. Another ground station that is used for the Campac rover to determine the position of the CanSat every moment. This is a picture of the map for the Texas competition that show the direction of the points of the CanSat that's followed by the purple line. We have also another MATLAB processing or ground station unit, and another one for the CanSat with the descent rate, air pressure, air temperature, and ground level altitude and battery voltage, and can generate KM file which is used to display the position on the Google Earth. This is our ground station with altitude and temperature and pressure on the graph. We have also Euler angle in 3 axes of x, y, and z. We have the acceleration and the angular velocity. We also have the temperature. The temperature in Kelvin and Celsius. We have the altitude in meters. We have 2 values. The first one is for the height of our reference line, which is the ground or the 0 level that we stand on, while the 21 meters is the level to the sea level. We have the pressure in a meter and in digital display. Then we decide to use processing that is so easy to use, and there is more things that we can do and develop on it. The printed circuit board. We have many PCB design programs that we work on it. It's 17 programs, but actually we will talk about 4 main programs. Altium Designer is one of the most important applications for the PCB design. It's so easy to use and have many professional things. No need to know what is the IC or the component do. You just need to know the number or the code of the IC to use in the circuit. It has many examples on it that show how to use it. Also, we have Eagle, which is one of the most important applications, but there is some problems that we prefer to not facing them. We have Protel 99, which is used commonly in some complicated circuit with so tiny lines like about half quarter of millimeter and so on. We have Aris, which is a part of the Protos. As we know that Protos consists of Aris and Isis. It's so easy applications, but it's not for beginners. We have Express PCB, which is one of the most easy application all over the world. It's for the factory in the USA that manufacture the PCB. Then, so we decided to use Altium Designer finally with all its features, which is so important features for everyone who want to learn how to design a PCB or a professional PCB. Let's talk about the recovery system. The recovery system, we have many things to use. We can use parafoils, we can use parachute or hold parachute, or something called 3D parachute. In the photo of the left, it's our CANSAT falling down with descent rate using parachute, while on the right, another team do a test for their Texas competition parachute. Yeah.
Okay, now we can get. Go on. Okay, go on.
Okay, complete now?
Yeah.
Okay. The picture on the left is the CANSAT parachute. It's our CANSAT parachute testing, and on the right is another team CANSAT parachute testing. This is a fact. Really, this is a fact. Okay, let's talk about what is the uses of the recovery system. When talk about the parachute, we have equations, we have fabrications, we have testing, and we have current project. We do not want the body to be in a state of a free fall. This means less control over the body and a constant increase in acceleration, which may lead to devastating landing forces with reaching to the ground. Therefore, we need to control a free falling body by controlling the forces acting on the body. So there is no need for acceleration. So we will say that the weight component and the drag component must be equal 0 of the subtraction of them. And we know from the aerodynamics formula that the drag equal half of the density of the free stream and multiplied by the square of the velocity of the free stream multiplied by the surface area of the parachute multiplied by a constant which is constant for the parachute. Everything we know, that is just the unknown is the surface area. Best case scenario is that you will have a body falling with a constant velocity or a constant descent rate. This would protect you from damage caused by landing shock and give you an estimation of how much time you would spend in the air. In other words, how much time you will have to collect data. Then, what about the drag? The drag is the main forces that we get from the parachute. Therefore, it will be the force through which we control our descent. What about the lift forces? Before talking the equations, we must know what is the things that we need to know. What is the kind of the parachute we need? So we have many parts or main parts like suspension line and spill holes. While when we're talking about the fabrication, we have the geometry, we have the type of the flat parachute, and what is the material we use. There are two most suitable alternatives. Each has their advantage and disadvantage, which is hexagonal and no-line parachute. Let's talk now about the hexagonal. To get the area, just use the drag equation and then calculate the sides length of the hexagonal. Hello, yeah.
One moment, please.
Okay. Hello,
Hello, hello.
yeah.
Yes, again, sorry, we have some problems with the internet connection.
Okay, no problem about that.
Okay, let me put again video and try to finish in, I think, 10 minutes. Is it okay?
Is it okay now to display?
Not yet.
Not yet. Okay, I will try again.
Can you hear me?
What? Okay, just a second. Is it okay now? Okay. Let's talk about the structure. That is the design of our CANSAT structure. When we talk about the structure, we have to talk about what? We have to talk about many things. Firstly, the inner design and the outer design. The inner design is some reps and so on, while the outer design talk about the container or the cover. There is some important criteria about the outer design that can withstand force during landing, allow you to access inside the component, and some component like GPS must be left open to the atmosphere or have a plastic cover, must suit the dimension. You can use any material that serves your design best. While when we talk about the inner design, there is some ideas for them. We have this structure that we have to produce a small structure for the Iran competition. If we look to the stress forces or the, the, the stresses on the body, we will find that all things in the lowest value, and the factor of the safety is so good until we reach to the ring on the top, which is here, which is that's one. At this ring we have the highest factor of safety, and the minimum factor of safety is 7 of 1000. This is a real photo of our inner structure. We have to use the circular shape because circular shape is good for have more loads than the plane or the smooth. This design consists of wood. The inner designer just, while the outer design or the outer structure or outer design of the structure is made of some technology of fiberglass that's to have more static loads. As the fiberglass is more toughness, there is some another view angle view of the body. Also, we start with a design of that, and finally we completed the design with the fiberglass. With the fiberglass, we do some tests by throw the body from about 30 meters height. The body hit the wall, but it's just a small scratch on the body, nothing more. It's so toughness, it's so tough in every conditions of this. And as we use some epoxy and some other drying material to paste them roughly, we actually didn't use any smart material. We just use some materials which is lightweight and so hard and tough. While talking about the mechanical system, as the mechanical system, we will make another change of the concept of the CANSAT. As in the in Texas competition, we have to have a CANSAT with two parts that separate at the height of 500 meters. And in some competitions, like Arles competition, the rocket reached to 15,000 meter, 15,000 feet. At this height, we need to some mechanical system to determine more data, like this CANSAT with two parts, the first one or the upper one and the one on the bottom. The one on the bottom have this shape with which is the have an egg in it, which called the payload. At a specific heat, we need to separate both of them in two parts at this point to be two separated parts. So we use servo. In this servo we have a payload, a small payload that's collect two parts together. At the specific heat servo, we send to the servo a control signal to rotate the servo to make the payload to throw down and the payload CANSAT or the lower CANSAT, and then separate in two separated parts to have this one on the right or on the left. This is the lower one, and this is the upper. They are fully separated. The one which is the upper, we have used something like parachute and the same mechanism of the parachute with no change, while the other part, which is the lower, must have a descent rate, another descent rate, like using parafoil, parachute, propeller, valve, anything that can be used to descend the speed or have a constant speed or falling speed rate. This is the full picture of the CANSAT. And this view, when we use the outer structure for both of them for more protection. This is another module or idea for using servo for separation. We have a ring, not completed ring. At the specific heat, it rotates in a direction, specific direction. To release the lander release at a specific heat. This design has many advantages, like we have the servo with its component in the upper one, or the upper CANSAT, with using battery in it, so we don't have a problem with the power of the CANSAT, while the lower have lighter and can not use so many powers. This is another idea, not time for discussing, because it's have another idea of compressed and uncompressed air. After all that, we need to do some tests to make sure that our CANSAT is suitable for tests or for the mission. We do some parafoils tests in some wind tunnels. We do some pressing tests or bending tests. We have some simulation on SolidWorks or another applications for simulation or material simulation. This is a real test in our university from about the height of 20 meters or less, I think. In this test, we test what the time needed to open the parachute. This is a real photo processing at which we photograph from or capture photo inside the CANSAT. Let's talk about some of our CANSAT that we do, which is the Iran competition CANSAT. We have the total weight of 265 grams with all components. We have that the structure is just 37 grams, which is so lightweight. Also, when we talk about the total power consumption, it's just 1 ampere per hour or 1 watt per hour, which is suitable. So we use Arduino because the usage of the power is so low, and there is some mode which is called sleepy mode. After a specific time, it shut down. We have the total cost of the CANSAT, which is about $152. Then we have another presentation about the Space System Technology Lab. In the Space System Technology Lab, it's based organization at Aeronautical and Aerospace Engineering Department. It was established in August 2011. The Space Lab, Space System Technology Lab activities increment through years. Talking about the activities and projects, the team won an Iran competition. They produced a solid structure design. They have the they have a creative design for some another microcontroller. This is a CTB4, and this is our team at the training time. After that, we talk about the CubeSat. CubeSat firstly talked about in 2008, and second, as they won the first first place for computer engineering in the Egyptian Engineering Day. We have rover pack or rover cam pack, which can control the navigation and go through lands to specific coordinates. We have also another structure for the CANSAT. We have in this picture have two kinds of CANSAT. One of them is CubeSat, is the CANSAT, while the other is rover cam pack CANSAT. Lunar rover, which won then so got one. It's not the 9th of in the competition. Yeah, we won in the URC competition. We have also solid rocket engines, and also we use some water rocket. We have a quadcopter with 4 rotor engines or motors, electrical motors. It's called a volleyball quadcopter. We have some research projects like jetpack and high power laser, which is in order to examine the soil for data acquisition purpose. We also have some training for the University Space Engineering Constituent, which is UNISEC. We have some training in some of the CLTB with Dr. Muhammad Khalil. Finally, now we talk about our aim. Our aim is to produce a CubeSat. We have a standard shape of the CANSAT. It's a cube with a length of 100 millimeter. But we look for some more development, like this Hexa CubeSat. It has many systems and it more applications and so lightweight. And this is a side view of it. It has a computer on it. Let us talk about our CANSAT, our CubeSat. Our CubeSat consists of 7 subsystems. One of them is direction control, as we think if I need to go towards the moon or to the earth, to the another planet or what. And the second subsystem is power module, which is called EBS module, and its mission is to supply or support the power that's needed for charging and discharging by the solar power, by the batteries and other systems. We have control, which means that if I looking with the CubeSat cameras to a specific direction and need to move to another direction, the structure also is a subsystem. The structure, how many weights or vibration affecting on it, and this is the photo of vibration testing for some CubeSat. We have onboard computer to take the data and make some decision to send some control actives, like sending control to the control signal to the systems. We have another orbit, which must the CubeSat follow a specific orbit with a specific speed and send data by some ways, and this phase is used to send that data at a specific time. We have also ground station that send the data from and to the CubeSat and another satellites. We have also some payloads like sensors, cameras, infrareds, and so on. Our aim is to make a module that's on the Earth and work on the space. We need to do some thermal tests for for the CubeSat in the future. We need more and more researches for the CubeSat to get that's one for our university to get proud of it. We need to produce some small integrated system with lightweight integrated system, advanced system, more intelligent designs, and creative ways. How to reduce the space to have a small CubeSat with more systems or subsystems on it. We have many questions about using microcontroller or microprocessor. Which kind of microcontroller? Sometimes we need to do some photo or video processing, so we need some microcontroller which is highly one. We need to produce some boards in small areas and send data and by antennas. One day we will have our CubeSat in the space. Thank you for listening to my presentation. If anyone have any question, he can ask me now.
Okay, excuse me, I can't hear you.
What?
Is your final presentation?
Yeah, it's the final.
Okay, let me, if there is some questions.
Okay, you can ask now.
Okay, una pregunta para Juan. Señor, una pregunta. What is the highest altitude that can be reached at the center?
I can't hear the question clearly.
Yes. Okay. The first question, what is the maximum altitude that can be reached?
Sorry, I can't hear the question clear. Can you come near to the mic? The microphone of the computer. Sorry, to hear it clearly.
Okay. The question is, how is the maximum altitude that it can touch?
Yeah, the maximum altitude depends on the sensor that we use. As we know, when we go up, the temperature go down to a point that our sensors cannot stay more, and they fall down. But actually, in Arles competition, the rocket reached to 15,000 feet, which is about 5 kilometers up, and it worked efficiently. Yeah.
Okay. Mustafa,
Yeah.
we appreciate your conference here. All the students are happy to listen to you.
That's kind of you, and I'm very happy for your opinion about my presentation and my preparation of it.
Podemos ofrecerle un aplauso a Mustafa.
Thank you, sir. That's kind of you.